Hey, this is lesson 13.2. We're talking about slope. If you'll recall earlier this year, we also talked about slope. So this should be a lot of review, just a couple of new things. So slope, the key idea, the slope m, we use m for slope, of a line is a ratio of the change in y, or the rise, to the change in x, the run, between any 2 points. Remember, it's the change in y over the change in x, or when we're finding change, we subtract, so y2 minus y1 over x2 minus x1. And here's the new part. When we were doing this earlier, or actually, let's look over here really quickly. The slope of the line is how fast it's going up, like this right here. The rise is what goes on top of our ratio, and the run is what goes on the bottom of the ratio. Rise over run. So now, the new thing would be that we, earlier this year when we talked about slope, we always had positive slopes. So the line was always going up like that. And when we were subtracting, we would subtract our y values and we put it on top. We'd subtract the x values, we'd put it on the bottom, and we never had to worry about keeping things straight because it was always a positive slope, always going up. Well, now we've got negative slope where it can come down. It's very important that we stay consistent here. So whatever we'll see what that means. y2 minus y1, x2 minus x1. We can't just willy-nilly subtract one way and subtract the other way down here, or we can get some wrong answers. So let's look here. Example 1. Describe the slope of the line, then find the slope. Well, this is a positive slope because as we're going from left to right, we're going up. And this is a negative slope because as we're going from left to right, this is coming down. So positive slope is going up, negative slope is going down. Now to find the slope, it's rise over run. So we can just look here and say, well, if we're starting at this spot here, we would have to go up 1, 2, 3, 4, 5 units. First, make sure that we're only going up by ones. Once in a while, that'll trick us. It'll go up by 2s or 3s here, but we're just going up by 1. So we go up 5. That's the rise that goes on top. And it goes over 1, 2, 3, 4, 5, 6. So 5 over 6 is the answer. The other way to find this is to put the change in y over the change in x. So let's look at the y terms. Remember, these are in xy. So the y terms are the second terms here. So now here is the reason that this becomes important that we put these in order. So change in y, let's call this where we'll start. So we'll put -1 on the top here. That's our first y term. And we'll subtract the second one, -4. Now, when we're down here, what I cannot do for my difference in my x or my change in my x, I cannot start with this one and put 3 minus -3. I have to start with the same point. So -3 and then -3. And when I do that, -1 minus 4 is -5. -3 minus 3 is -6. Because the top and bottom are both negative, they cancel each other out, and we just get 5 over 6. Okay, which we already knew because rise over run was 5 over 6, but that's how we can find it with the change in y over the change in x. Same thing over here. Now this is a negative slope, so our rise is actually a -3. It's coming down. So it's still called our rise. It's not called a drop or anything, but our rise is a rise of -3, so that would go on top. And our run it's still going left to right, so 2. -3 over 2 is the slope of this line. But let's do that with the change in y over change in x like we did on the first one. And so we'll start with here, 1 minus -2, minus -2, okay? And now we'll start back over here with our x, so -1, because our x's go on the bottom, -1, -1. Well, 1 minus -2 is the same as 1 plus 2, which is 3. And -1 minus 1 is -2. -2. So we could just write it like that, 3 over negative 2, but what we'll usually do is we usually pull that negative out front or put it up top. We rarely leave the negative in the denominator. I'll put it right out front here, negative 3 over 2. So it's a negative slope, meaning our line's coming down. And right here we had negative 3 over 2 for rise over run. And now we see it's negative 3 over 2 doing the change in y over change in x. Of course, we would come up with the same answer. Now, if you look what they did, a slight difference here, on both of them actually. They started on their first one here, example 1a, instead of doing negative 1 minus 4 and negative 3 minus 3, they did y2 minus y1. And they just switched their points around. They did 4 minus negative 1, 3 minus negative 3, 5 over 6. And then they didn't have both negatives. They just had 5 over 6 right here. Of course, you still get the same answer as long as you stay consistent. Same thing over here. I did 1 minus negative 2. Well, they did negative 2 minus 1. It's okay because on the bottom, instead of doing negative 1 minus 1, they switched those around and they did 1 minus negative 1. They got negative 3 over positive 2 or negative 3 over 2. Same answer, because they were consistent. And now over here on page 575, we've got some on your own problems to do. So for number 1, because these points are right on the intersections here, it's pretty easy to do just a rise over run on them instead of doing the subtraction problems. And when you can, let's take the easy way out. First of all, it's going to be a negative slope because it's coming down like that. So when we're all done, we better make sure our answer is negative. But first we'll do the rise over the run. So rise over run, you don't have to write this out, but just so you know what I'm doing. So our rise is negative 1 because it's coming down 1. So our rise is negative 1, and our run is 1, 2, 3, 4, 5. So negative 1 over 5 is the slope. And we knew it had to be negative because the line was coming down anyway. For number 2, this will be a positive slope. We can see the lines going up. If we start here, it goes, these are still going by 1, so we're good. It's going up 1, 2. So the rise of 2 and a run of 1, 2, 3, 4, 5, 6. So the slope is 2 over 6 or 1 over 3. And number 3, it's a positive slope because it's going up as we go from left to right. Our rise is 1, 2, 3, 4, 5. It went up 5. And it went over 1, 2. So our slope is 5 over 2. And we'll leave it in fraction form. We're not going to put it in 2.5. We'll just leave it as 5 over 2. On this next part, the example 2, we have finding the slope of a horizontal line. So here's a horizontal line like that. If you've ever gone skiing, you can ski down a slope like this, kind of like a bunny hill there, but you are going, and you can go down a hill like this. You'll be going fine. Down a hill like this, that's pretty scary actually. My kids would want to do that. I would not. But if you went on tried skiing along that, you wouldn't go anywhere. Why? Because there's no slope. There's zero slope. Well, if we did this, just rise over run form, we would say that it went up 0. So we would put it went up 0 for our rise, and our run was 1, 2, 3, 4, 5, 6, 7 here. And 0 over 7 is the same as 0. Or we could do our change in y over change in x. Let's start with this point this time. We'll subtract that point. It really doesn't matter which one. But we'll do 5 minus 5 over 6 minus negative 1, which is 0 over 7, which is what we started with. And that is equal to 0. So a horizontal line has a slope of 0. If you want to remember when you're skiing, if you ski along something like that, you're not going to go anywhere, okay? If you're a cross-country skier, you can push yourself along, but just using gravity, this will take you absolutely nowhere. Then we have finding the slope of a vertical line. Same kind of thing, except, wow, if you're going to ski down this, okay, that's not even a double black diamond. That's just a death wish right there. You ski off here, and by the time you hit the bottom, they won't be able to figure out who was skiing there. It's just going to be a blob. You would be undefined, which is bizarre because that's what we call this slope right here, an undefined slope. And we'll see why. We can do change in y over, well, first of all, let's do rise over run. So rise over run here. And the rise was 1, 2, 3, 4. And the run, it didn't go any to the right. So it would be over 0. That's like dividing by 0. 4 divided by 0. You can't divide by 0. It's illegal in most states. Well, we could do change in y over change in x. Same kind of thing here. We'll do 6 minus 2, 4 minus 4, which would give us 4 over 0, which again is dividing by 0, and you cannot do that. Because division by 0 is undefined, the slope of this line is undefined. Here are a couple more on your own problems, still page 575. Find the slope of the line through the given points. Well, if you look here, I don't see a graph. I don't know what the slope could be, positive, negative. I have no idea. So I can't really do rise over run with this, but what I can do is my change in y over change in x. So we'll go negative, these are the y values, remember, on the second one. So negative 2 minus negative 2, negative 2 minus negative 2, 1 minus 7 for my denominator. So 1 minus 7 for the denominator. Well, negative 2 minus negative 2 is the same as negative 2 plus 2, which is 0. And 1 minus 7 is negative 6. Well, it didn't really matter what we had down here because a 0 on top means that this is a slope of 0, which remember means it's a horizontal line. So it's a horizontal line. For, oh, that's not number 1, that's number 4. For number 5, same kind of problem. And we can see the y values are the same, so it's going to turn out to be the same kind of thing here. But 4, take away 4 on the top, and then negative 2 minus 3. Negative 2 minus 3, 0 over negative 5, which is still just 0. So it's a slope of 0. It's a horizontal line. For number 6, we have negative 3 minus negative 5 over negative 3 minus negative 3. Well, this is the same as negative 3 plus 5, which is 2, and negative 3 plus 3, which is 0. 2 divided by 0, we can't divide by 0. This is not a slope of 0. This is undefined. Number 7. Eight minus 0 for the numerator, 0 minus 0 for the denominator will give me 8 over 0, which again is not a slope of 0. It is undefined. And number 8. How do you know that the slope of every horizontal line is 0? How do you know that the slope of every vertical line is undefined? Well, for number 8, how do you know the slope of every horizontal line is 0? Since it's rise over run, the change in y is 0. So the numerator will be 0, which makes this 0. For how do you know the slope of every vertical line is undefined? Because the change in x will be 0, which is our denominator, which means we would be dividing by 0, which makes it undefined. So if we were going to write that out, I would write because the change in y is 0 for the first part, and because the change in x is 0 for the second part. Excellent. Example 4 says finding the slope from a table. So the points in the table lie on a line. How can you find the slope of the line from the table? What is the slope? Well, you can use any 2 points here. Remember, these are each points that are on the line. So we have 1, 8, 4, 6, 7, 4, and 10, 2 because they go x, y because they're ordered pairs. So we can choose any. It looks like for the example, they chose the first 2 that they gave us, 1, 8, and 4, 6. And then they just turned it right into the slope formula, change in y over change in x like we did on the previous problems. 6 minus 8 is negative 2. 4 minus 1 is 3. So negative 2 over 3 or negative 2 over 3. The slope is negative 2 over 3. A nice check would be you could, if you had some graph paper laying around, you could plot each of the points, draw your line in there, and then do a rise over run. Well, the on your own problems for this, the points in the table lie on a line. Find the slope of the line, so number 9. And we can pick any of the points. We'll choose just the first 2 because that seems to be easiest. So really we have 1, 2, and 3, 5 are the 2 points that we're going to use. We'll do the change in y on the top. So 2 minus 5, 2 minus 5 for my change in y, 1 minus 3, 1 minus 3 for the bottom. Now somebody else might have done 5 minus 2 and 3 minus 1. We'll get the same answer in the end. 2 minus 5 is negative 3. 1 minus 3 is negative 2. I have a negative on top and bottom, so they cancel out to give me a slope of 3 over 2. And then for number 10, same kind of problem. This time, I'm going to choose, let's do the first one, which would be the point negative 3, 6. And I'm going to choose the origin, that's always nice, 0, 0. So now when I do my change in y, I've got 6 minus 0 for my numerator, and negative 3 minus 0 for my denominator, which leaves it just 6 over negative 3, which is the same as negative 6 over 3, which is the same as just negative 2. And then finally, a little summary here. It says for slope, positive slope, the line rises from left to right. Negative slope, the line falls from left to right. Slope of 0 is just a horizontal line. And an undefined slope is a vertical line. I would suggest that you go on and do some of the odd problems, checking your answers in the back, and then move on to the homework for section 13.2.